Welcome to lesson 7131, sinusoids and transformations. When they say sinusoids, they mean the sine and the cosine. So now we're going to be looking at changing our windows so that we can see the graph, our viewing angle on our calculator. So Desmos TI-84, Calculate 84, make sure you had these ready to go. Okay, here's our vocabulary. Take the time to read through that. Some more vocabulary, pause, and take the time to read through it. Okay, so let's highlight some things. This is key. A, B, C, and D. If you go back and study our transformation works, A, B, C, and D, or H and K, whatever, all did different things. And so they're going to do different things to the sine and the cosine wave. So the amplitude is the absolute value of A. That's amplitude is the distance from the midline. It tells you how high you are from the midline on a sine or cosine. The period gives you the amount of waves. And the frequency is how many waves occur per period. So we're going to pay attention to where the numbers are. If they're in front of the X, if they plus or minus to the X, and these actually should be plus minus. That should be, you can't see that, I'm sorry. Let's see, this should be plus minus. This should be a plus minus right there. That's in white, you can't see white. That should be plus and or minus. This should be plus and or minus. And we'll talk about that when we get to the transformations, the difference between the plus and the minus. Okay, let's look at our first example here. Vertical stretch or shrink and amplitude. Okay, so this is my suggestion. In the last video, we showed you how to change the windows and how to put the cosine X and the sine X into the calculator. Now we're going to be using some numbers. So what you want to look for is where is the number. The cosine X has no number in front of it, and mathematicians are lazy. They don't like writing ones because ones multiplied to anything don't do anything. Okay? So in a regular cosine, that is not the absolute value symbol, there should be a 1 in front of the cosine and a 1 in front of the angle. But since 1 times anything is that thing, mathematicians ignore it. Now, in Y2, we have 1/2 cosine X. This changes the amplitude because it's in front of the cosine. So all of our values shrink by 1/2. So the regular cosine is going to look like this. At 1, at -1, at pi degree, pi radians, and at 2 pi radians, it's going to go back to 1. So 1, 0, 0, 1. So it's going to go and curve back up and then curve back down. So that's that one. So now let's look at B. What B will do is take every point on a graph and shrink it by 1/2. So instead of starting at 1, we start at 1/2. We still go through 0. We go to -1/2. We still go through 0, and we go up to 1/2. So this is what this curve is going to look like, and you should draw these out on your calculators. Now the -3, because it's out front, is an amplitude shift. What does that mean? You take your 1 and you multiply it by -3. So our graph is going to come down and start at -3. We're still at the same 0 because we didn't do anything else. So a negative will flip the cosine upside down and increase its distance from the midline by a factor of 3. That, remember, we take the absolute value of the number. So for this one, the distance from the midline is 1/2. The normal cosine has a distance from the midline of 1. And what's the midline? That's where the graph intercepts the x, well, not necessarily the x-axis. That's the point it goes from. So the amplitude is from the midline. So if it's a 1 amplitude, it's not the total height of the wave. It's not the maximum and the minimum. Is the amplitude of 1 is the height from the midline. Okay, in our next example, we're going to look at horizontal stretch or shrink and period. So, the white one is a graph of the sine. You can't see the white, so that's the first one. So A is the first one. A is in white. So what you're going to do is grab your calculator. You set your windows 2 videos ago. Just go back and reset your windows so that we can see an entire graph. I did not graph the left half of this. I'm just graphing from 0 to 2 pi to make it easier on us. We get one full wave because I just want to analyze one full wave. All right, now in B, -2 is an amplitude shift. And then now we have a period shift. And we said, what's the period? You had to take the original period to get the new period. The new period equals the original period divided by the B. And the B has to be in front of the number, not added or subtracted from it. And that's a B, not a 6. So we know that the original period of the sine function is 2 pi. Now we're going to divide that by 1/3. And why is it 1/3? Because 1/3 times x equals x over 3, if you understand your fractions. And then we know when dividing fractions, 2 pi over 1 times 3 over 1 gives us 6 pi. So this means we get one full wave in 6 pi radians, or you should see 1/3 of the wave in your window. So for B, the negative means we go negative first, so we go down to -2. So if I go down to -2, I start my graph at 0, and I'm at my negative at pi, I'm at -2, because that's the amplitude. So my max and mins get stretched, but at 2 pi, well, a little past 2, because our period has changed, my lowest point is a little bit past pi, and I only see 1/3 of the wave. So this is all you're going to see. And if you look on the left side, but I'm only analyzing from 0 to 2 pi. Okay, now let's look at C in a different color. 3, my amplitude gets stretched to 3. So let's put that on this graph, and then you're going to put this in the calculator to confirm it, and it's away from the midline. So -2x. -2 is my B, so that means my period, I get 2 waves. But what happens, the negative is going to flip the graph around backwards. So I'm going to go down again and up. If I went left, I would go up and down, because you know this white one, if you have negative the angle, the whole graph flips around the y-axis. So you're going up from right to left and down, up from left to right and down from right to left. If I extend, let me extend the white one. So this is what it should look like on the other side, something like that. Basically, when I flip this around, if I spin the y-axis around, our new one is going to go up this way and go down this way. So what we're going to do is put it in the calculator. You already have your window set. So 3 sine, negative is down at the bottom, 2x close your parentheses just out of habit, and then graph it. And what's going to happen? You're going to see 2 waves in the same period. So it's going to go down to 3. It's going to come back up. It's going to go down and come back up and come down. So now we have to calculate the period. So our original period was 2 pi, and we're going to divide that by -2, which gives us a period of -pi, or just pi. So we should get 1 full wave, and I didn't draw this accurately enough. We should get 1 full wave every pi radians, and then 2 full waves every 2 pi radians. So that's what that does to the angle. Okay, now let's look at example 3. They want us to change the windows. So now you're going to change your x values. Your x min is -3 pi. Your x max is now +3 pi. So go ahead and change the windows. And your y min is -4 and your y max. I think we said our graph was set up by pi over 2, but we're going to change the window. But the first thing we need to do is figure out the period. So we have a pi over 3 situation here. I would change my x scale to pi over 3. And why is that? This is going to help us see where the zeros are. All right, so remember, the sine has a period of 2 pi. So change the windows, and now let's come back and analyze. Change the windows on the calculator. Let's come back and analyze. So the new period is the old period of 2 pi divided by 2/3, which equals 2 pi times 3 over 2. And the 2's cancel out, which gives us a period of 3 pi. So this is going to stretch our wave. So we're going to clear out y1, y2, and y3. We're going to change our windows, and we're going to stretch. Now, when they say frequency, the frequency is the new change divided by the original period, the b divided by the period. That's what they want us to do. So if we take 2/3 and divide it by 1 over 2 pi, because when you divide fractions, you flip them upside down, you get 1 over 3 pi as our frequency. So if you flip that back over, you get your period. So basically, and now we got a 4. So this means our sine goes from a height of 4 to -4. If I do pi over 3, I'm going to get a lot more. So I get 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi, 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2 pi, 7 pi over 3, 8 pi over 3, 9 pi over 3, which is 3 pi. And then to go around twice is 6 pi. So 3 pi was that 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3. If I'm doing pi over 3, 3 pi is a period. I should get a full period at 3 pi, so I went too far. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. So I should get a full wave at 3 pi. That's what I should get. So I'm going to change my windows and come back and graph it, and then we can see what we get. Okay, if we look at the graph on our calculators, we see that we reach our height a little bit past 2 pi over 3, the come back to 0 in between 4 pi over 3 and 5 pi over 3, and we go down to -4, and we come back up at 9 clicks. So it's easier when you set your windows up to match the graph to see the viewing window. It's not exactly perfect, but this is just a sketch. So we do that. Now, if you feel nervous that you don't see the top of the graph, you can always go a little bit past the height of 4. You can go to like 4.2 or 4.5 if that makes you feel better. So I went to 4.5, and you can actually see the top and bottom of the graph. So we get one full wave at 9 pi, at 3 pi radians, which is 9 pi over 3, or 9 dots on our x-axis. And this is why we change the x scale. So your denominator of a fraction, use that as your scale, and that will help you be accurate on your period. Okay, so write the cosine function as a phase shift of the sine function. So the cosine of x equals the sine of x plus pi over 2. Now, when we have plus, that means a graph will shift left. And we learned this in transformations. Because of the nature of the equation, plus, when you add an angle to your x value, it shifts the graph left. So that is the sine function. All right, now we're going to do the sine function. So the sine of x,
please proceed to your next class,
is equal to the cosine of x minus pi over 2. And we know that minus means your graph shifts right. So basically the sine and cosine are the same. They're shifted over pi over 2 radians, or 90 degrees, left and right from each other. Okay, now let's look at this example. Construct a sinusoid with a period of pi over 5. If I pick up the right tool, pi over 5, and an amplitude 6 that goes through 2, 0. Okay, so now our new period is pi over 5. So the new period equals the old period divided by the b. So the period of the sine and the cosine is both the same. It's 2 pi, and we're going to divide it by pi over 5, which gives us 2 pi over 1 times 5 over pi. Pi's cancel out, leaving us with 10. So this is our b, which is 10. Or no, I'm sorry, not our b. This is not our b. This is our new period. Okay, so now the amplitude is 6, meaning, okay, so if we take our equation, y equals a sine b x plus or minus, I don't know, they call it h, we could call it c, doesn't really make a difference, plus minus d. Okay, where a is your amplitude, 6 goes in there, your sine of 10 for x. But now it goes through 2, 0. So if it's to the right, we shift it right, minus 2. Minus is part of the equation. It's like a long time ago in Algebra 1 when you was doing slope-intercept form. The minus is part of the equation. It does not shift up or down, so we don't have to worry about that. And now we distribute the 10. And we get 6 sine 10x minus 20. And this is your sinusoid. You can always graph it and check. Make sure you graph it and check. But you're going to have to change your windows because now this says 2, 0, which means you got to take pi out of your x values. Okay, so let's see what we got here. Construct a sinusoid that rises from a minimum value of 5 to a maximum value at 25. So if I draw the graph, we have a minimum value at 5. It goes up and it comes back down, and it has a maximum value when x equals 32 to 0. Our point here is 25. So now to find the amplitude, we need to worry about the midline. So that yellow line is the midline. Okay, so we do 25 minus 5. This is going to give us our amplitude, A. We're going to divide it by 2. So 20 over 2 is equal to 10. This is our amplitude. And now, this is half the period. Well, the maximum is 1/4 of the period. Okay, so we go from our minimum to a maximum and then back down to the minimum. If 32 is halfway between, this has to be 64. So this is the upside down cosine. So that means our amplitude is -10. That's our A. Because the cosine starts at the minimum or the maximum. If it starts at the maximum, it's positive. If it starts at the minimum, it's negative. So we take 2 pi, divide it by 64, reduce your fractions. That's 1 pi over 32, which equals our B. So you get y equals -10, the cosine, pi over 32x, close the parenthesis. Now we need to figure out our midline. If our midline is 10, subtract 10 from 25, add 10 to 5, and you get 15. And that's our vertical shift up. So go do some practice problems.